Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on the line of best fit. So we're actually looking at bivariate data now, which is data involving two variables. So when we did box plots, for example, we might make a box plot of, say, your test scores. But that's only one variable. The only thing that changes from person to person is your test score. Now what we're looking at is the relationship between two variables. So we might look at the relationship between people's height and weight. Height would be one variable and weight would be another variable. So we usually observe these relationships using what's called scatter plots. So we have diagrams like this, two axes. Each axis represents a different variable. And what we do is we have a whole heap of points. So each of these points represents an observation that has two values. One value for the first variable, one value for the second variable. So I'm just going to plot a whole heap of points here in this scatter plot. So this scatter plot could represent the relationship between the temperature and ice cream sales. So we might say this one here might be if it was 20 degrees Celsius, making, say, $200 in ice cream sales. Each of those points represents an observation. That observation has two numbers, one representing the temperature, one representing ice cream sales. So here I could have another scatter plot where the vertical axis here is BMI, body mass index. So if you don't know, a higher number indicates that you're more overweight. And along the x-axis, I have hours at the gym. So these are both numerical variables. If I ask you what's your BMI, you're going to give me a number. If I ask you how many hours do you spend a week at the gym, you're going to give me a number. So we've got two numerical variables, and each of these points in the scatter plots represents a different observation. I made a third scatter plot, this comparing shoe size and your maths result. So note, we normally have the independent variable on the x-axis. So remember, variable is one of the things we're measuring. So independent means it doesn't depend on the other. For example, in the first one, the temperature outside doesn't depend at all on how much ice cream is being sold. But the amount of ice cream being sold depends on the temperature. Similarly, in the second one, your number of hours spent at the gym doesn't depend on your BMI, but your BMI is influenced by how often you exercise, and so on. So you'll become a little more familiar with the concepts of independent and dependent variable later. I'm not going to test you on this. I just want you to know, because people always ask me, how do I know which variable to put on the x-axis and which on the y-axis? It doesn't matter hugely at this point, just letting you know we normally put the independent variable along the x-axis. So what we want to be able to do with these scatter plots is comment on the relationship. So firstly, we want to decide whether or not the relationship is linear, and if there's a relationship, is it positive relationship or negative? So firstly, let's look at whether or not the relationships are linear. So linear means you can draw a line through the data points. So for the second one, BMI and hours at the gym, that's very strongly linear. I can easily draw a line through the observations. So it's very clearly a linear relationship. Now in the first one, ice cream sales and temperature, I can kind of draw a line through it. So this relationship is linear. It generally follows a straight line, although this isn't strong. So just so you know, there is a definitive way in mathematics to determine the strength of a linear relationship, or whether there is a linear relationship. But we're not going through that in Year 10. All you need to be able to do is just look at it and say, oh yeah, a line generally can be drawn through the data points, or whether it can't. So for the third one, shoe size and maths result, there isn't a linear relationship. You can't really draw a line through the data and capture most of the data points. So we would say the relationship is non-linear, or there's no linear relationship. Because wherever I draw a line here, or if I draw it here, there's no one line that kind of captures most of the data points. it's not clear where to draw the line. So that relationship is not linear. So now let's determine whether the relationship in the first two is positive or negative. So what is happening here is as temperature is going up, ice cream sales are generally going up. So as one variable increases, the other one increases. So we would say that this relationship is positive. That's what a positive relationship is. As one variable goes up, so too does the other. And you would expect that relationship to be positive. You'd expect that you would sell more ice cream on hotter days. Of course, this doesn't mean that if the temperature's warmer tomorrow, you absolutely will sell more ice creams than you did today. It just means, in general, you expect to sell more ice creams as the temperature goes up. So the relationship in the second one is negative because what is happening is as the number of hours at the gym is increased, as we go along here, the BMI is decreasing. So as one of the variables increases, the other decreases. That's what a negative relationship means. And you'd expect that. You'd expect that the more hours you spend at the gym, your BMI would decrease. You'd be less overweight. Again, I'm not saying that this is absolutely definitive. If you go to the gym more, your BMI will definitely 100% decrease. It's a generalization. As you spend more time at the gym, generally your BMI will go down. So we don't really comment on whether this one here that had no relationship would be positive or negative because there is no relationship. And that makes sense. I mean, you wouldn't expect that your maths result has anything at all to do with your shoe size. Okay, so that's just going through looking at scatter plots and determining the relationship. Now we're going to create a scatter plot of our own. So here I've given you a set of values and we're comparing the hours of study with maths score. So you'd expect there might be a positive relationship. The more study you do, the better you score in your test. So what we're first going to do is draw up a scatter plot and plot each of these points. So now I've ruled up my scatter plots. I am going to plot each point one after the other. So note it's your score that depends on the number of hours of study, not the other way around. So that's why I put hours of study, the independent variable, along the x-axis. So the first one is 0.85. So that will be like up here. And then I plot 4.81 and so on. So each of these columns here going down is a point in the Cartesian plane, and I'm sure you know how to plot them. So I'll just go ahead and plot the other 8. So after plotting all the data points, I can see that there is a linear relationship. It's not perfect, but I can generally draw a line that is close to all of the observations, and the relationship is generally positive. As one variable is going up, as the number of hours of study is going up, generally the maths score is increasing. So what I'm going to do now is draw a line of best fit by eye. Now there are heaps of ways that you can draw the line of best fit, but I'm going to give you one of them. So we're going to draw our line of best fit so that it goes through at least 2 points. We're going to do that because we actually want to calculate its equation. And to calculate the equation of a line in the Cartesian plane, you need at least 2 points. And we want roughly the same number of points above and below the line so that the distance from the line, the average of the distance from the line is roughly 0. You don't need to worry too much about that. Just make sure there is about the same number of points above the line as below the line. So if I pick this point and this point and draw a line through, I get this. So I have a line that goes through 2 points, and there are the same number of points above the line, 4 above the line and 4 below the line. So this line in green is my line of best fit. So what I'm going to do is calculate its equation, so then I can use it to predict values of one variable if I know the other variable. So I'm going to calculate the equation of this line. Remember, the equation of any line is y equals mx plus b. M is the gradient and b is the y-intercept. So the first step is to find m. Remember, I used the 2-point formula, y2 minus y1 over x2 minus x1, just like I did in term 1. So the 2 points I have this point which is 1296, and the other point I have is 481. So the gradient is y2 minus y1 over x2 minus x1. So that just gives us 15 over 8. I found m, I now need to find b. So remember, I do that by substituting m and either of the points into this equation. So I'm going to substitute y for 81 and x for 4. So that's what I need to do to find b. So if I rearrange this equation, I get b equals 73.5. So then the equation of the line is y equals mx plus b. So that is the equation of my line of best fit. So I'm going to turn over to a new slide. Please pause and copy this down if you need. So I have my equation from the previous slide. Y, the score in the maths test as a percent, is equal to 15 over 8 times x, which is the number of hours studied, plus 73.5. We're going to use that equation to answer these questions here. This line of best fit that we found, it's not perfect. It's just, in some sense, as close as possible to all of the data points. And we're going to use it to make predictions. So firstly, we're going to predict a person's math score if they study for 9 hours. Well, x is the number of hours. All I need to do is substitute x for 9 and find y. So if I put that in my calculator, I get 90.375. I'll just round to 90.4%. So that's the prediction from my equation. Again, it doesn't say someone absolutely will score 90.4% if they study for 9 hours. This just gives us an idea of what we might expect them to score if they study for 9 hours. So what about if they study for 40 hours? Well, we do sort of the same thing. We just substitute x for 40. So 15 over 8 times 40 plus 73.5. So the answer we get here is 148.5%. And alarm bells should be going off. That's just silly. They're not going to get 150% or close to it. So why is it that the one for 9 hours seemed reasonable, but the one for 40 hours didn't? Well, 9 hours, when we were finding that, that's actually called interpolation. So this is reliable because 9 was within the x values that we had, the actual data points that we had. If you flick to the previous slide a few minutes ago in this video, you'll see that we had x values ranging from 0 to 12. So this is considered a good or a reasonable prediction because x equals 9 was in the original range of values. For x equals 40 hours, this is extrapolation, and that's bad. We didn't have x equals 40 in our original range of values. And that's where you can get silly answers like this. So this equation is really only useful for the range of values that we had. We had range of values from x between 0 and 20. If we substitute an x value outside this range, if we substitute an x value that we weren't originally given in our data points, then the results are unreliable. So extrapolation is unreliable because 40 hours was not in the original range of values, and so this answer here, as you'd expect, is unreliable. So for the last one, for how many hours did they study if they scored 98? So that's easy. Now we're substituting y, because y is the score as a percent, for 98. So I get 98 equals 15 over 8 times x plus 73.5. And you know how to solve this equation. I subtract 73.5 from both sides. And now I'm going to divide each side by 15 over 8. So the answer I get is 13.06 recurring, so it's about 13.1 hours. So if I want to get a mark of 98%, according to this equation, I should study for around 13 hours. Now, this is, again, reliable because 98% was in the range of y values that we were given. So that's the whole point here. What we do is we get two variables, we plot them in a scatter plot, and we find the line of best fit. We find a line that's as close as possible to all the values. If it goes through two data points, we can calculate its equation and use that equation to predict one variable if we know the other variable. All right, I know this is a bit complicated. Please ask if you have any questions. Thank you so much for watching. This has been the luckiest maths teacher in the world. Have a great day.